In this lesson, we are going to learn how to measure mass in grams. Yesterday, we learned how to measure mass in kilograms. Let's review the smallest unit of mass, which is the gram. A paper clip has a mass of about 1 gram. A centimeter block also has a mass of 1 gram. Lastly, a piece of gum has a mass of 1 gram. We can abbreviate the word gram by using a lowercase g, so we don't have to keep writing out the word gram. Let's do an example together. Suppose we have one paper clip. The mass is 1 gram. Suppose I ask you to find out the mass of 100 paper clips. Hopefully you're thinking in your head, if 1 gram is equal to 1 paper clip, then the number of grams for 100 paper clips would have to be 100 grams. What if I ask you to find out the mass of 10 boxes of paper clips, each with 100 paper clips in each box? Now you could do this a couple of different ways. You could say, well, I know that I've got 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000 grams altogether by skip counting. So we know that 1,000 grams is equal to 1 kilogram. So we could also say that the mass of 10 boxes of paper clips, each having 100 paper clips, would be equal to 1 kilogram. Today we're going to learn how to measure smaller masses using a balanced scale. Now, balanced scales take longer than digital scales, but they can still be used. Let's review what a balanced scale is. First of all, a balanced scale has a balanced beam and 2 pans. What you need to do is put the object that you want to find the mass of on one of the pans. Suppose you want to find the mass of an apple, and you place it on one of the pans. This pan would actually drop. It would lower probably all the way down to the ground. And then what you are going to do is have some masses that you're going to add to the other pan. And you're going to add the masses onto the other pan until the pans are balanced. So if you had some masses like 20 grams, you could keep piling them up until the 2 pans are balanced or at equal heights. And you would just skip count 20, 40, 60, 80. 100 grams would be the mass of your apple. So when the pans contain the same mass, the beam is balanced. Let's actually do an example together using a really cool animation. Let's try to find out the mass of a banana. Let's measure the mass of this banana using a balance scale. So the object of trying to find the mass using a balance scale is to level off the 2 pans so that they're at equal heights. Now notice that we've placed the banana on one of the pans and the pan has dropped and the other pan has gone up. What we want to do is try to bring this other pan down. So what we need to do is add masses to this pan to bring this pan down so that it will be at an equal mass as the banana. So I always start with the heaviest mass that I have, and that is 1 kilogram. So let's drag 1 kilogram over to this pan and see what happens. Now 1 kilogram is too heavy. It causes the pan to go below the banana. We need to put that back. Let's try 500 grams. 500 grams is too heavy also, so we need to put that weight or mass back. Let's try 200 grams. 200 grams is perfect. So we want to choose a mass that is going to still remain higher either let the pan be higher than the other pan that's containing the object that we're measuring the mass. Okay, because we want to keep adding masses to bring that pan down in a slow manner. Let's try adding 100 grams now. Oh, see, now 100 grams is too heavy, so we need to put that 100 grams back. So far we're good with the 200, but we know that if we add another 100, it's too heavy. Let's try 50 grams. Perfect. So we know that the mass of the banana is equal to 200 plus 50 grams, which is 250 grams in total. The two pans have balanced out, and that is our goal when we're measuring the mass using a balance scale. Okay, so hopefully that provides you with a little bit more information about using a balance scale. So if you were to have a picture like this, and I asked you to find out the mass of this banana, you would see that the two pans are at equal levels and that you would just add up those two masses to find out the mass of the banana. So you would add 200 plus 50 is 250 grams. Let's measure the mass of this soccer ball. Let's measure the mass of the soccer ball. So again, let's start with 1 kilogram, move it over, and it is actually too heavy. So we know the soccer ball is lighter than a kilogram. Let's try 500 grams. Oh, so we know that the soccer ball is heavier than 500 grams, but lighter than a kilogram. So let's add 200 grams to our scale. So that's too heavy. We have to take the 200 grams off. How about we add 100 grams? Oh, that looks good. So we have 500 plus 100 is 600. Let's keep going and see if we can balance the pans. Oh, that's too heavy. So let's take 100 off. Let's try adding 50 next. Still too heavy, so we need to put the 50 grams back. Let's try 20 grams. Ooh, this is good. So we have 500 plus 100 is 600 plus 20 is 620 grams. And I don't have another 20 grams to work with, but I have 10. So let's try adding 10 next. And look at that, we've balanced out our two pans so that they are equal heights, which means the mass on this pan is equal to the mass of the soccer ball. So let's add this up. 500 plus 100 is 600, 620, 630. That's the mass of our soccer ball, 630 grams. Okay. So let's take a look at the picture of the balanced pans. So again, we would add up those masses. 500 plus 100 is 600 plus 20 plus 10 is 630 grams. And that is the mass of our soccer ball. What is the mass of this deck of cards? Here I've just given you a picture of the balanced beam. And we know that the two pans are at equal heights above the ground. So indeed, we've done this correctly and we've measured the mass of the cards properly. So we just need to add up these masses. 50 plus 20 is 70, plus another 20 is 90, plus 5 is 95 grams. That is the mass of the deck of cards. How about the mass of this pineapple? Now, we would add up 500 plus 500 is 1,000 grams plus another 200 grams. Now, there's two ways to write this. You could write it as 1,200 grams or 1,200 grams, or 1 kilogram and 200 grams, because we know that 1,000 grams is equal to 1 kilogram. Let's take a look at the mass of this jar of peaches. Now this is my kitchen scale that I use at home, and I just placed this jar of peaches on top after I zeroed it out. And if you take a look, it's measuring the unit that it's measuring the mass of the peaches is in grams. The lowercase g means grams. So let's take a look at the number. It's 1,018 grams. That's our mass. Or we could say we know that 1,000 grams is a kilogram, so we could say this is also equal to a kilogram and 18 grams. Let's take a look at measuring an object like a pair of scissors using both methods. First, let's measure the mass with a balance scale. If you add up the masses, 20, 40, 60, we know that our scissors are 60 grams. What if we put our scissors on a digital scale like I did at home? What is the difference in the mass that you see? Well, here, my digital scale measured the scissors to be 57 grams. Now, sometimes scales can differ a little bit for lots of different reasons, lots of which is calibration and maybe not zeroing it out properly, or even just human error. What is the difference in mass? Well, difference means to subtract. So we would say 60 grams minus 57 grams is equal to 3 grams. That's the difference between these two scales. Let's do another example looking at digital scales. Which object is heavier, a can of soup or a rock that fits in the palm of my hand? So the soup you'll see is 338 grams and the rock is 328 grams. So hopefully you're thinking to yourself, 338 is bigger than 328, so we would put a check mark or circle the soup. How about this example? Which object is heavier? A cell phone, which is 171 grams, or a big head of cauliflower, which is 1 kilogram and 200 grams, or 1,200 grams. So hopefully you're seeing that the cauliflower is almost 10 times heavier than the cell phone. So definitely put a check mark beside the cauliflower. Now let's look at these three objects. I want you to put them in order from lightest to heaviest. So the soup is 338 grams, the orange is 220, and the rock is 328. So hopefully you're seeing that the orange is the lightest, then the rock, and lastly, the heaviest is the soup. So it goes orange, rock, soup. Your assignment today is to complete pages 80 and 81, and of course take a picture of your work and submit it. Tomorrow, we are going to do a Kahoot review for your unit test, which will also be on Friday. So make sure you're caught up with all your work, grade 3s.